I'm very pleased to say that we have Sayak Paul joining us as our second speaker. Sayak is a deep learning associate at PyImageSearch, so his work skews towards deep learning, particularly within computer vision use cases. Sayak, if you want to share your screen, take us away.
So hi folks, thanks for joining in. I'm Sayak. I'm a deep learning associate at PyImageSearch. I work at the intersection of deep learning and computer vision. Really pleased to be here. And I'm from India. It's like 11:10 p.m. But no worries. I'm anyway happy to be here to be able to speak to you about TensorFlow Hub, which is kind of a holistic repository of state-of-the-art machine learning models. So if you have any questions about the kind of things that I would discuss throughout this session, keep noting them down, keep posting them to the QA window, and I'll try my best to answer them. Okay. So the ideal audience for this session would be machine learning developers that have already worked with TensorFlow and Keras, because as the name suggests, it's TensorFlow Hub, so you cannot really plug in other frameworks in here. Although we can theoretically use ONNX and stuff like that, but I'm not going to go that route today. So this is going to be the rough agenda of the session. I'll be briefly walking you through what TensorFlow Hub is to make it a bit more complete, why it might be useful. I'll also be demoing you the UI of TensorFlow Hub. That's tfhub.dev, and the improved one, not the classic one you might have been used to. I'll be also demonstrating a number of use cases where you may see the true potential of using TensorFlow Hub modules, and of course Q&A would be at the end. So I'm just going to shamelessly read out the official statement as to say what TensorFlow Hub is. So TensorFlow Hub is a collection of state-of-the-art pre-trained models published by different teams within Google, as well as community contributors like NVIDIA, Microsoft, and so on. So now coming to the motivation behind actually developing TensorFlow Hub based modules and developing TensorFlow Hub, the concept of TensorFlow Hub in the first place is like many of us might not have the kind of gigantic architecture on which the big companies train their models and stuff like that. So here's a little meme that I prepared, so excuse me for that. So yeah, so one of the primary objectives behind developing TensorFlow Hub is to really make state-of-the-art machine learning models more and more accessible to researchers and machine learning practitioners, so that they can make use of those models off the shelf and take advantage of world-class results at the same time. And also for machine learning researchers, it might be very useful because they might be running a number of different ablation studies to try out different models very quickly. And this can in turn result in much faster iteration cycles. And the second reason is really to enable a number of, rather a large number of developers to make use of state-of-the-art machine learning models without having to require much of machine learning expertise, because one of the main visions behind developing TensorFlow Hub is to really enable non-ML audience take advantage of state-of-the-art pre-trained machine learning models. And there are a number of different pre-trained models available on TensorFlow Hub, as we would see across a number of different tasks and number of different domains, such as image, text, audio, video, and so on. And they also include a number of different tasks as well, as you would see. And of course, it also enables developers to push back their state-of-the-art models. So if you have any state-of-the-art models trained in TensorFlow, consider giving it back to the community through TensorFlow Hub. So it provides a very unique platform to give back to the machine learning developer community as well. So the very feeling that your model is gonna be consumed by a number of different developers, companies, and organizations, I guess that's a very satisfying feeling. So I'm gonna be quickly demoing tfhub.dev. That's the UI of TensorFlow Hub, and I think it's going to be pretty useful for you. So this is the improved UI, which was launched during TensorFlow World last year. So as you can see, it's kind of a search engine for TensorFlow based models that do across a number of different domains and a number of different tasks. Let's say I am searching for a mobile net model. So I'll just search for mobile net and I'll get all the different things. So you will get typical cards for each of these models. And if you just click on it, you will see the number of different things that are available with this particular model. So it has the kind of documentation you would need to get started, the usage and the kind of training dynamics that was followed while training it and stuff like that, and basically all the vital information that you might need to use this particular model. And this particular one is for running off the shelf in image classification. But if you are more interested in sort of using the headless model, that is to extract features from your images and stuff like that, so that's also possible with this. And here's an accompanying collab notebook that will showcase how to use this model as well. And it's available across a number of different formats, as you can see. So let's see if a TensorFlow Lite variant of MobileNet is available or not. It looks like it's available. So yeah, here you go with the TensorFlow Lite model. It's also available. So you can just download it and use it straight away by reading out the documentation and stuff like that. So I think it kind of makes our lives a bit more easier. There's TensorFlow JS as well, and you might be familiar with accelerator devices like HTPU USB accelerator by Coral. So the models that are compatible on Coral, those are also available out here. So it's pretty cool, I would say. So as I was mentioning about different problem domains and stuff like that, so let me go back to tfhub.dev again. So you might want to search for video based models and stuff, and it's available. Let's say you want to put a filter like TF2. Of course, there isn't any available models on video data that's in TF2, but what about TF1? Yeah, we have. What about TF Lite based models? No, we don't have stuff like that. And the task here is for video classification, and you can search for architectures as well. You can specify publishers, data sets on which it was trained on and stuff like that. So basically it's kind of a very systematic search engine for the models that were trained using TensorFlow. So it's pretty cool, I feel. So that was like a very quick demo of TensorFlow Hub's UI. That's tfhub.dev, and I really encourage you to check it out and see the kind of models available there and see if they fit your use cases. So as we saw, there is a plethora of different models spanning across different domains, spanning across different tasks along different domains and stuff like that. So yeah, again, I would really encourage all of you to check it out and see how they kind of creep in your use case. So as I mentioned, I would be also walking you through a number of different usage scenarios as to how to use TensorFlow Hub models in classic deep learning use cases. So image classification is pretty much one of the most favorite tasks of almost all the deep learning practitioners, I would say. So here's an example of using a TensorFlow Hub model to run off-the-shelf image classification. So here's how you would specify a URL to a particular TensorFlow Hub model. So in this case, we are using the MobileNet v2 that I just showed you a bit earlier. So you would need to specify that particular URL. Then you would just load it into a Keras sequential model. By the way, this code is in TensorFlow and Keras. So I would also assume that you are familiar with TensorFlow and Keras. So here's how you would load this particular TensorFlow Hub model into a Keras layer, and then you would wrap it into a Keras sequential model. You can also specify the input shape of the images that this particular model would expect in case the model that does not support dynamic input sizes and stuff. So after you prepare this particular TensorFlow Hub module, then you can just run the inference as it is, and then you can post-process all the logics that you would get from this predict API call. So I have also linked the example to the full code here. So I'll be anyway sharing my presentation deck with all of you, so that you can refer to it when it's needed. So let's take another more common scenario that's doing image classification using transfer learning. I think it's applicable to a number of different use cases, and it's also highly beneficial as well. So again, here we would using the head part of a particular classification model. We are only interested in the headless part. That is the layers without the classification part, typically the fully connected subnetwork within the big CNN network, I would say. So here you would specify the URL to the headless model first. Then you would load into a Keras layer, same as before. Then you would construct your final model, just adding a classification layer on top of the feature extraction layer, and you can compile it and fit it to your own custom data set. And as you can see, this feature extraction layer can be set to trainable or non-trainable, because oftentimes you might want to also fine tune those already learned features. So in those cases, you would start with the pre-trained weights, and then you would want to fine tune it. So in that case, you would want to set the trainable parameter of the feature extraction layer to true. And if that's not needed, you can set it to false. So it's up to you. So yeah, the point here is that flexibility is there with you, but it's also important to note that not all of the models available on TensorFlow Hub support this, but most of the models do. So yeah. Okay, so here's another uncommon example, I would say. So TensorFlow Hub provides you with state-of-the-art style transfer models. So I think this is one of the most favorite parts of this is one of my one of the most favorite parts. So yeah, so let's say this is the content image and this is the style image with which we would want to transfer, we would want to run style transfer, and this is all the code that's needed in order to generate a stylized image like this one. So this is all of it. I mean, without the imports and image preprocessing operations, this is just 4 lines of code, and you can get a beautiful stylized image like this one. So feel free to check out the demo that I have linked here, and yeah, feel free to also share your results and tag the TensorFlow team on Twitter if you want to. And here's another example, another very useful and beneficial example, I believe, text classification, again, by facilitating transfer learning. So TensorFlow Hub comes up with a number of different pre-trained embeddings, and here we are using the GNU's Sphereable embedding, which has 20 dimensions in this case, but TensorFlow Hub does provide the higher dimensional one as well. And this also has trainable parameter which can be set to true or false, as you would see. So same way, you would start by specifying the URL to the embedding TensorFlow Hub, where the embedding is hosted on TensorFlow Hub.dev. Then you typically load that embedding into a Keras layer by specifying all the important parameters, and then you would just create your final model and you would compile it and fit it. It's really as simple as that, right? And I think you would now appreciate the kind of ease you get with TensorFlow Hub, and it really does enable you to iterate faster and faster in your development life cycles. I have also linked to the fully worked out example, which you might want to try. Also feel free to test out different embeddings and see how the results are changing. And recently TensorFlow Hub also added the big transfer model, which is currently the state of the art for a number of different computer vision tasks. It also has BERT-based models as well hosted. So yeah, feel free to check them out and let the TensorFlow Hub team know about it. And TensorFlow Hub does provide models for other tasks across a number of different domains, as I had mentioned. For example, object detection, and a number of pre-trained embeddings are available, not just the Genius swayable one. It has universal sentence encoder and a number of different text embeddings as well. So feel free to explore more on tfhub.dev. I'm sure you will like it. And you can publish your own models, like I mentioned before. If you have trained a state-of-the-art model which you would want to share with the broader community for people to actually consume your model and use it and benefit from it, consider publishing your state-of-the-art models to TensorFlow Hub. And in this link, you can find all the necessary stuff that you would need to follow for that. So slides are available here, and I have also given this link to Inga. She might be sharing this with you via chat so that you can refer to the deck as needed. And yeah, thank you. And I would love to connect with you all via Twitter. I'm on Twitter. My Twitter ID is Rising Sayak, RISING SAYAK. So that's all from my end, and I'm open to questions.
Thank you, Sayak. That was really useful, and I'm just posting in the link to your slides, and obviously this recording will be available through our TensorFlow channel as well. A couple of questions for you. TF Hub has been around, I think, since 2018. But do you have any view on kind of what the growth of its catalog has been in that time? What kind of expectation of models within its library?
Yeah, sure. So when TensorFlow Hub was launched in 2018, it did not really have these different model formats that I just presented. Like you have TensorFlow Lite pre-trained models, you have different even models in TensorFlow JS, and models supported by the Coral USB accelerator and stuff like that. So I can definitely say that when it started back in 2018, the library of the models has grown substantially, because it now has a number of different models that I just showed across a number of different tasks and domains. So definitely it has improved, and also it has grown substantially.
Very good. And there was a question from the attendees as well. There can be many models that obviously do similar tasks. Do you have any tips to help users refine and find the best models for their problems?
Yeah, that's a very good question. So the way we go about it is, like, let's say I have to deploy a model to a mobile device or an embedded device such as Raspberry Pi or something like that, I would typically start with a very lightweight model like MobileNet. I won't take a model as heavy as VGG16 or ResNet 50 or even EfficientNet. By the way, TensorFlow Hub does provide you the TensorFlow Lite version of EfficientNet. It's called EfficientNet Lite, so you might want to check it out. But yeah, on the other hand, I would really first see what kind of scope that I'm catering to, what kind of target runtime my model would be deployed to. If it's again mobile devices or embedded systems such as Raspberry Pi, I would try with models like MobileNet first, and then if the performance is not satisfactory, then I would move on to other more complicated architectures. So that's how I kind of decide about it. So the long story cut short here is, I first decide where my model would get deployed to, and then accordingly I decide the architecture that I would use first.
Very good. We have a landmine of a question from Dr. Koller. He asked the question, which one is best, LSTM or RNN, recurrent neural network, or CNN, convolutional neural network, or GRU? Do you take a view on this, Sayak?
Yeah, of course. I think it depends on the kind of task you are at, and also it depends on the kind of data set and the kind of dependencies you are trying to model. Because if you take a text classification problem, someone might argue that you should definitely try out LSTMs first, but there has been a lot of discussions and concussions around using 1D convolutional neural networks to exploit the locality of the spatial patterns that a text piece might have. But it really depends. Like most of the things in machine learning, like there's no free lunch theorem. The beauty of machine learning is it's often more alchemy than science. So you might want to experiment with a number of different models first and then take the decision. So with experiment and with experience, with the virtue of experiment and experience, you will eventually be able to decide for a given data set and for a set of given traits for a data set. This would be the model that I would try first, and this would be the model that I would not try first. But then again, your assumptions might get broken out of nowhere. But it's not really your fault. It's the way machine learning most of the time operates. So yeah.
That is definitely my answer of the evening. Fabulously dealt with. So unless we have any other questions from our attendees, it just remains to me to say thank you, Sayak, for speaking and contributing to this evening's meetup.